All right, let's dive right in. Today, we're going to be data detectives. We're on a mission to solve the mystery that, let's be honest, drives every single one of us crazy. The case of the painfully, unbelievably slow Snowflake query.
You know that exact feeling, right? You hit run, you walk away, maybe grab a coffee, come back, and that little wheel is just still spinning. It's so frustrating. But here's the thing I want you to get. It's probably not your fault. That slow query isn't just a bug. It's a breadcrumb. It's a clue that points to something much bigger and often much deeper, going wrong in your data architecture.
So, to crack this case, we need the right tool. And in the world of Snowflake, our number one tool, our high-powered magnifying glass, is the query profile. This is where we find the evidence. It shows us exactly what Snowflake is doing, step by step, under the hood. It's how we're going to find the culprit.
Okay, so our investigation officially begins. First up, we need to identify the usual suspects. We're going to use that query profile to spot the common bottlenecks that are killing our performance.
In my experience, it almost always comes down to one of these four, what I call the four horsemen of poor performance. First, you've got excessive table scans. That's literally like reading the entire phone book from A to Z just to find one name. Then you have exploding joins. This is when your join logic goes crazy and joining a million rows with another million rows somehow creates 100 million rows. Not good. Third, remote spillage. This is a huge red flag. It means your query ran out of fast in-memory RAM and had to start writing data to slow remote disk. And finally, you've got queuing. Pretty simple. Your query is just stuck in traffic waiting for other jobs to finish.
So these are the symptoms, right? We can spot them in the query profile. But a great detective doesn't just stop at the symptoms. We need to find the root cause. And believe it or not, so often, all four of these symptoms can be traced back to one single fundamental mistake in how we built things.
And here it is. This is the big one, the main villain of our story today, the nested view trap. It's a super common anti-pattern, and it can bring even a powerhouse like Snowflake to its knees.
So what exactly is it? Well, you have to remember what a view is. It's not a table, it's just a piece of stored text, a saved query. So when you nest them, you build a view that selects from another view, that selects from another view. You're not making things simpler. You're building a Russian doll of complexity. At query time, Snowflake has to take all that text and smash it together into one giant, monstrous query. This thing is so complex, it completely confuses the query optimizer, and it ends up creating a horrible, inefficient execution plan. And this isn't just theoretical. The danger is very, very real. I mean, look at this quote from the source material. A real-world example, a query that was fine, took 30 minutes, suddenly jumped to 4 hours. Why? Because somebody made one tiny change to a view that was buried deep down in the nest. That's the trap. It's a ticking time bomb in your code. So, what do? The solution, the core principle, is this. We have to stop doing all this incredibly complex work at query time. We have to stop asking the database to perform a miracle the second a user hits run. All right, we've identified the villain. Now it's time to introduce the hero of our story. This is the gold standard architectural pattern that's gonna save the day. And here it is. It's a simple, powerful, three-step automated pattern. Step 1, we take all that complex logic from our nested views and we materialize it. We run it once and save the results in a real table using a create table as select statement, or CTAS. Step 2, we wrap that logic up neatly in a stored procedure to make it easy to manage. And step 3, we put the whole thing on autopilot using a Snowflake task to refresh the table on a schedule. We do the hard work ahead of time, so when your users query the data, it's already there, clean, and ready to go. It's blazingly fast. Now, I know what you might be thinking. Hang on. Why go through all this trouble? Why not just use Snowflake's own built-in materialized views? And that is a great question, but there's a huge, deal-breaking catch. This table tells the whole story. Let's zoom in on the most important row here. Supports joins? A regular view? Yes. Our automated CTS pattern? Absolutely. But look at Snowflake's native materialized views. The answer is a hard no. They can only work on a single table. Since our entire problem is based on complex logic that joins multiple tables, they're fundamentally the wrong tool for this specific job.
Okay, so we've built our new table. We've solved the architectural anti-pattern. We are in a much better place. But why stop at better? Let's talk about how to make this thing absolutely fly. This is where we go from fast to truly supercharged, and it's all about how we physically organize the data when we store it.
The secret weapon here is a technique called clustering. Here's the deal. Snowflake stores all your data in tiny little files called micro-partitions. Clustering lets you tell Snowflake to physically sort those little files based on a key, like a transaction date or a customer ID. It's the exact same idea as sorting a phone book by last name. If you need to find Smith, you can just jump straight to the S section. You don't read every page. In Snowflake, this is called pruning, and it is the absolute foundation of high performance.
And the effect is, well, it's just mind-blowing. Look at this chart. On a typical query against an unclustered table, Snowflake might have to scan 980 out of 1,000 partitions. It's reading almost everything. But you add a good cluster key to that same exact table, and suddenly it only needs to scan 5 partitions. 5, not 980. The performance gain isn't just a little bit, it's astronomical.
Whew, okay. We've covered a lot of ground. We've talked symptoms, root causes, new architectures, and supercharging techniques. So now, let's put it all together into one simple, actionable playbook you can take with you. Think of this as your new field guide for performance tuning. It's designed to connect the clues you find directly to the solutions we've just talked about.
This is your cheat sheet. It's super practical. You see a symptom in the query profile, and this table tells you the cause and the fix. For example, you see a huge amount of time spent in table scan? That's your clue. The cause is bad pruning, and your solution is to add a cluster key. You see any remote disk spillage? The cause is your warehouse ran out of memory. The fix? Scale up to a bigger warehouse size. It turns diagnosis into immediate, confident action.
So after all of this, if you only remember one single thing, please let it be this. The secret to fast, scalable analytics is to stop doing complex transformations at query time. You have to shift that complexity. Do the heavy lifting ahead of time, on a schedule, and land the results in clean, well-structured, clustered tables. That is the game. And so I'll leave you with this final thought. Now that you know what to look for, now that you can spot the nested view anti-pattern from a mile away, how many of these hidden performance traps, these ticking time bombs, are lurking in your own data models right now? Go be the detective. Go find out.